metals and nonmetals. Okay, metals are found on the left side of the periodic table. They form positive or cations. And then the last one is they lose electrons to become stable. Nonmetals are found on the right side of the periodic table. They form negative or anions and they tend to gain electrons to become stable. Now, if you remember from first semester, all of the elements in the periodic table like to be stable, not necessarily neutral, okay? So if we take a look at a periodic table, which for this part, I'm going to go ahead and scroll down to our periodic table. Okay, so if you are taking paper notes, you can outline the periodic table in some way, or you can cut and paste or find, be creative and draw your own periodic table. But just to kind of refresh your memory about the periodic table, you have a staircase on the periodic table. And I'm going to draw that staircase in for you. Okay. And when we say the left side of the periodic table, we're talking about over here. So these are all your metals. And then to the right of the staircase, these are all your nonmetals. And then if you guys remember oxidation numbers, that's the outer shell on each element. And the outer shell contains, I'm going to go through the numbers here so you can see this, but the outer shell contains, in this first row, 1 valence electron. In the second row, you see the 2 on top. That's 2 valence electrons. And then what happens is we tend to skip these guys. These are called your transition metals. We tend to skip over those because they do some funny things that we'll talk about a little bit later on. And then we jump over to your nonmetals. Oh, actually a combination of nonmetals, semimetals. This section here, these guys have 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and then lastly, these guys are your happy guys, your noble gases, right? These guys have 8 valence electrons already, which means they are not going to become cations or anions. They're going to stay nice and neutral and happy to be left alone. Okay, so now let's go back to our notes. Now we're going to do part 2, and that's going to be, oopsies, let me close that for you guys. Here we go, part 2. In our objectives, we want to identify some important terms. All right, the first term that we want to identify is the term bonds. This is a strong force of attraction. Holding atoms together in a molecule or crystal. We'll talk about that later. Caused by transferring or sharing electrons. The second term that I want to talk about is ionic bonds. Key word here for ionic is the transfer of electrons. And I'm going to write this word in here, valence electrons. That means the outer electrons on an atom or element, generating oppositely charged ions. So that's ionic bond. And the key word here is this word transfer. Okay. And then the last term is covalent bonds. The key word here is this word sharing. This is the sharing of valence electrons. One thing you want to note is when elements share, they share pairs. So keep that in mind when we're talking about covalent bonds, all right? So again, you have bonds, you have ionic, 2 types of bonds, ionic and covalent. Ionic, they transfer. Covalent, they share. All right, so I have 2 pictures for you. In the first picture, we're going to talk about Li, lithium. Lithium has 3 electrons. Has 2 shells. Okay, and this guy right here is the valence electron. And then we're going to bring in fluorine, F. Now fluorine also has 2 shells, 2 energy levels, 1, 2. And fluorine has 2 electrons in the first layer and 7 on the outside. In order to be stable, fluorine wants to have 8. It's closer to 8, so needs 1 more electron to be stable. And then lithium happens to have this lone electron. So what lithium is going to do is it's going to transfer that electron over to fluorine. So now you have lithium, just got a little smaller, but it's happier. It lost an electron, so it becomes more positive. Fluorine is happier because it has now 8 valence electrons. And don't forget, it borrowed 1 from lithium. So fluorine now has an extra electron. That makes fluorine negative. And because opposites attract, lithium is going to be attracted to fluorine, and here you have a bond. So these guys are bonded. And we call this an ionic bond. On the other side, you have what's known as a covalent bond, and for the covalent bond, I'm going to use 2 chlorine atoms. So we'll use 1 chlorine atom, has 7. Valence electrons, and then another chlorine atom, which has 7. And so what's going to happen here with these two is if we can get them close enough, they're going to end up sharing this pair right here. And so now we have chlorine, and there's 2 of them. Now, neither one is a cation or an anion because they're sharing the electrons and they're sharing the pair of electrons. So you've got 8 over here and 8 over here, just not at the same time, right? They're sharing, passing those electrons back and forth. And that's our covalent bond.